Hey guys, today I'm going to teach you all about literal equations. By the end of this lesson, you'll be able to rearrange multivariable equations or formulas to isolate a given variable. So go ahead and get your binder, turn to the math section. Let's go take some notes. Before I jump in and tell you what literal equations are, I just wanted to show you some examples and non-examples of literal equations. These are literal equations and these are not. So before I tell you, what do you think makes something a literal equation? The key difference between these examples and these non-examples is that literal equations have more than one variable. In all of these non-examples, they're still equations, but we can actually solve for the given variable and figure out what that missing number is. However, in a literal equation, there's more than one variable. So all you're going to do in these literal equations is rearrange them to solve for a specific variable. Formulas in geometry are actually a really great example of literal equations. Here are some that you may have seen before. For example, area equals base times height, the Pythagorean theorem, or volume of a prism. Now that we've defined literal equations and seen some examples, let's start solving 1- and 2-step equations and then apply those same practices to the literal equations, starting with the equation in box A. If we wanted to solve for B, how would I get that variable by itself? Hopefully you remember that to isolate a variable, you have to use the inverse operation. If B is being multiplied by 4, we would have to divide by 4, and if we do it to one side, we have to do it on the other. In this case, we can do 144 divided by 4 and get B equals 36. Now let's look at the literal equation. And what you'll see is that there's a given variable in parentheses that we want to isolate. So I want to get the variable f all by itself. To do that, we want to use inverse operations. And just like in the last example, when you have a number and a letter together, it means they're being multiplied. So even though it's two letters, we know that E and F are being multiplied, and we want to undo the times E. So we would divide both sides by E. E divided by E is 1, so we're left with just F on this side of the equation. On the other side, I don't know what D or E represent, so I'm just going to leave that as D over E, or D divided by E. And this is the same equation that we started with, it's just been rearranged to solve for F. Do the same thing in box B. First, you should solve this equation for x. Go ahead and do that now and press play when you're ready to check. Hopefully you remembered that to solve a two-step equation, you would pay attention to what I did in red. You would undo the addition or subtraction first, so subtract, then you would divide. We're going to do the exact same thing in the literal equation to solve for the variable m, just like you solved for the variable x. Get rid of your addition or subtraction first. So in this case, if you see that plus b is in the way, let's get rid of it by subtracting b. And if you do it from one side, you've got to do it from the other. But since we don't know what y is, we can't take b away from it. We're just going to write y minus b. And then bring down everything that's left. You still have an m times x. Take a minute and think about what's the next and last step you should do to isolate m. Hopefully you realize, just like in our last example, since m and x are being multiplied, and you want to get m by itself, you would divide both sides by x. And if you do it to one side, you have to do it to the other. Since x divided by x is 1, your equation is now solved for m. m equals y minus b all over x. So that's how you solve a literal equation for a given variable. I want to give you a chance to try at least one of these next 4 by yourself. So take a minute and try C, D, E, or F before I show you how to do all 4. All right, looking at C, the first thing that I would realize is that 5 times 12 is 60. So I know that if I have those numbers together, I can go ahead and simplify that. Since I'm solving for H, I would divide both sides by that product. So I get 6 equals H. And I can apply that same process and thinking to the literal equation to solve for the variable H. L and W is a product, just like 60 was a product here. So I can actually go ahead and divide by LW all in one go. I can divide by LW from both sides. V divided by LW is H. For D, I'm actually going to solve the equation and the literal equation at the same time so you can kind of get a better idea of what I'm doing solving for this given variable. 2 times 7 in this equation is just like MJ in this equation. It's two things being multiplied. Since they're numbers, I know that 2 times 7 is 14. They're the same thing. Either way, my first step is to take that product and subtract it from both sides. Since in the literal equation I'm solving for K, I'm going to do the exact same thing. I need to start by subtracting mj, just like I did in this equation. The only difference is that in this equation, I know that 70 minus 14 is 56. But in the literal equation, h minus mj can't be simplified. We would just write h minus mj. On the other side of the line, mj minus mj is 0, so it's gone. And all that's left on this side of the equals is 2 times k. Now let's go back to this equation. The last step to solving is to divide 2 by both sides. We're going to do the exact same thing in the literal equation. You want to get k by itself, so you're going to divide 2 by both sides. So in the actual equation, we know that n equals 28. In the literal equation, all we can do is rearrange the values, which we did. K isolated is the same thing as h minus mj all over 2. In the one-step equation in box E, we multiply by 2 to get the x by itself. When you do that, you end up with 150 equals x. You do the exact same thing in the literal equation. If you want to get q by itself, you need to get rid of that divide by r. To get rid of divide by r, the inverse operation is multiply by r. And if you do it to one side, you have to do it to the other. So q equals t times r, or r times t, or just more simply, rt. To solve for c in box F, we would start by subtracting 144 from both sides, and then do the opposite or inverse operation of squared, which is take the square root. So c equals the square root of 25, which is 5. We can do the exact same thing to solve for x. First, you would subtract y squared from both sides, and then to isolate just x, we need to do the opposite of squared, which is to take the square root. And if you do it to one side, you have to do it to the other. So x equals the square root of z squared minus y squared. Now that you've seen some examples, I want you to try number 1 all by yourself. This example is just like box C on the front side. Let's do number 2 step by step. If we're trying to get y by itself, what do we need to get rid of on this side of the equation first? You need to get rid of the plus 8x. We get rid of addition with subtraction. If you do it to one side, you have to do it to the other. The last step is to get rid of the times 4. Divide both sides by 4. Then we can actually simplify. If we're dividing out a 4 from each of these terms, we can write 4 divided by 4 is 1. So you're left with 1y. Negative 12 divided by 4 is negative 3. Negative 8 divided by 4 is negative 2. And then you have x. So you could have written it y equals this, but you can simplify it one step further and rewrite it most simplified to be y equals negative 3 minus 2x. All right, for number 3, we are getting c isolated, so we need to get rid of that times m. We do that by dividing by m, and if we do it to one side, we have to do it to the other. Then you have to get rid of that squared. The way to get rid of squared is to take the square root, and if you do it to one side, you have to do it to the other. The square root of e divided by m equals c. Go ahead and try number 4 all by yourself and press play when you're ready to check. The first step is to take away the product of c and d, and if you do it to one side, you have to do it to the other. Last step, since you're trying to isolate a, is to divide both sides by b. So the literal equation should read a equals e minus cd in the numerator divided by b. So for number 5, go ahead and take a minute and compare and contrast solving literal equations with equations containing one variable. You may have said something different than me, but I want to share that I noticed that both equations are solved using inverse operations. So even when it's just letters and variables, we don't have the numbers. We're basically doing PEMDAS backwards. We're solving equations even though there's no numbers to isolate a variable. And that's the key difference. Equations with one variable give you just one numerical answer. But in literal equations, there's still variables in your answer, and that's okay. It's just rearranged. And sometimes that's beneficial, especially when we're given formulas. So we're going to look at some applications of solving literal equations, starting with number 6. If we know that the formula for the perimeter of a rectangle is P equals 2 times the length plus 2 times the width, and we want to find the width of the rectangle when we know the perimeter and a length, we might find it useful to rearrange the equation to solve for W. Go ahead and take a minute to do that now. Your first step would be to subtract the 2L from both sides and then divide by 2. Now that the equation is solved for W, or the width of the rectangle, it's really easy to plug in these values and evaluate this expression. Since 244 is the perimeter and 59 is the length, all you'd have to do is plug this into your calculator to determine that the width is 63 inches. For number 7, we're eventually going to try to figure out the temperature of a room in Celsius if it's 95 degrees Fahrenheit. Let me show you this without creating a literal equation solved for C. You could plug in 95 for F, and if you do that, you'd have to solve your equation for C by subtracting 32 from both sides, then dividing both sides by 9/5. Dividing by a fraction is the same thing as multiplying by the reciprocal. When you divide by 9/5, you're doing the same thing as multiplying by 5/9. When you do that, you get 35 degrees Celsius. Now let me show you how to solve the equation for C. Start by doing the same thing. Subtract 35 from both sides. Then you would want to get the C by itself by dividing by 9/5 from both sides. But whenever you have fractions and fractions inside of fractions, it looks very confusing, and math people want things to look as simple as possible. So instead of dividing by a fraction, you could see this written as being multiplied by the reciprocal, which means flipped fraction. This is probably the best way to rewrite this literal equation or formula for C, and you would do it the exact same way now if you wanted to plug in 95 for F, and you would get the same temperature in Celsius, 35 degrees. All right, keeping all of that in mind, I want you to try number 8 all by yourself as much as you can, and then press play when you're ready to check. All right, let's break this down one step at a time. The first thing we need to realize is that we're solving for H, so we need to get rid of the times 1/3 and the times B. Let me do this one at a time and get rid of the times B first. Now I'm left with V over B equals 1/3 times H. Since I want the H by itself, I need to divide both sides by 1/3. And just like in that last example, mathematicians don't like to divide by fractions. Instead, we multiply by the reciprocal. So instead of writing divide by 1/3, we're going to write times 3. And if we do it to one side, we have to do it to the other. If you aren't sure where the 3 should go, top or bottom, think of it like this. You're multiplying by 3 over 1. That's the reciprocal. So 3 over 1 gets multiplied by that, which means that the 3 should go on top. And your literal equation solved for H is 3V over B. The last part of the question, Mr. Trill tells his students the value of the two variables are 2,198 centimeters cubed and 314 centimeters squared. But he doesn't tell you which variable goes with which number. How can you determine the value of each variable given this information and what you may remember about volume of a cone? Hopefully you remembered that volume is always cubic. So that's going to be the 2,198 because it's centimeters cubed. Area is squared. So area of the base would be 314. That's how I knew to plug those numbers in to those V and B spots. When you do that, you end up with the height of 21 for this cone. And that's it. Thank you for watching. If you have any questions, please let me know. Bye.